Let's look at these questions here. So they're asking us to give the volume of a round chocolate. The round one, it will be the cylindrical one. Triangular, it's this other one here. All right, volume of a cylinder. Volume of a cylinder. In your head, volume of a cylinder should always be pi r squared h. In other words, the same as base area times the height. Base area times the height. So volume of a round chocolate will be there. Take note, what's given to us? Okay, it's already a radius, which is okay. And we have the height. So just come down here, we shall say, we said volume equals to pi r squared h. So it will be 3,142 times 18,5 squared times the height, which is 10. Please don't put the 10 here and you change. You substitute according to the formula. 3,142 times 18,5 squared times 10. The volume ended up being 10,753,5 millimeters cubed. Why am I putting cube? Because I'm looking at volume. All right. So we come down there, we look at volume of a triangular prism, the triangular chocolate. Now what we're going to know, let me first number. The slanting sides, these ones are the S. Together. The sides are the S. Then this part from here up to there, it will be the height of the prism. Height of the prism is 10 millimeters. Then we have also the height of the triangle, which is 43,3. The sides, they're telling us how big are they. It's 50 millimeters. Everything is in millimeters, which is okay. So let's go. So volume of the triangular prism, look at what they're telling you. So volume of the triangular prism, remember I told you base area times the height. When you look at it critically, it will be the same. Anyway, let's come and we shall say volume of a triangular prism, it will be half times S, which is this one side, we said it's 50 millimeters, times the height, which is 43, the height of the triangle, then times the height of the prism, which is 10. So this one ends up being 10,823 millimeters cubed. So they're asking us, calculate the total surface area of the round chocolate. Now, total surface area, you come here. They've already told you total surface area. It's 2 pi r into r plus h. So we shall say 2 times 3,142 times. Take note. Remember the radius, we had it as 18. 18,5. You come here, you put your 18,5. Open brackets is still 18,5 plus the height, which is 10. The height, which is 10. So you end up having 3,313,24. This is area. Leave it as millimeters squared. Please, when you are looking at these questions, you pick the right formula and substitute accordingly. Where you see radius, you put radius. Where you see the height, you put the height accordingly. Don't just substitute. All right, let's take note. Total surface area of a triangular chocolate. So here we go. We have it as it says. Total surface area of a triangular chocolate. It says S times H plus 3 into S times H. So one is which is the 50 millimeters times the height of the triangle, which is 43,3 plus 3 into the same S, which is 50 times 10. Please substitute the way it is. Here, let me come back here and show you. Side of a triangle, this is the S. Height of the triangle, which is the small h, and height of the prism, which is the capital H. Yeah. So here you know it that my S 50 millimeters, my small h will be, and my capital H is the 10. Why am I saying that? Because they have already defined them down here. S, the side of a triangle. H, the height of the triangle. H, capital H is the height of the prism. Come here and you see side of the triangle H. So here S is 50. The small h, side height of a triangle. Height of a triangle. You see what it is. Then you come here and you say height of the prism. Height of the prism. That's what I followed. Then I came, summarized, put them down here. I went ahead and substituted. Please, measurement is all about substituting if you're given the formula. So my S, I open my bracket. I see S, I put a 50 because S is 50. Times, I see the small h. I see the small h, I put 43,3. I close those brackets. I bring the plus. I put the 3 outside. Open the brackets again. I find another S, which means it's times the capital H, which is what? 10. I put everything in the formula there. I end up having so I have the answer as 3,665 millimeters what? Squared. That's how we do it. That is question number 2.1. Sorry, 1.2. Let's look at 2.1. 2.1, it says the box shown below is used to pack 80 rectangular chocolate bars. The measurements of the box are length of 28 centimeters, width of 15 centimeters, the height of 8 centimeters. So this is the box used to pack these small chocolates. Now we're there. So they are starting with calculate the volume of the box using the formula. Please, as I've said, as volume equals to length. So ask yourself, what's the length? The length here they have told you it's 28. Please, this is supposed to be 28. Times, what's the width? The width is 15. Put 15. Then what is the height? The height is 8. Put the 8 there. Put in your calculator. End up having the answers 30,360. These are centimeters cubed. Okay, we go to the determine the thickness of the chocolate if the area of its base is 35 centimeters squared. It's supposed to be squared here. Represent area. So what we're going to do first and foremost, we already have the area of the base. Area of the base. This one is missing. What about the volume? So you will ask yourself, how are you going to get the volume? Remember in the scenario, it says the box takes how many? 80 chocolate bars. So if the box takes 80, it has a volume of this much. What about only one? What's the volume of only one chocolate? So you will take, it becomes 3,360 divided by 8. I'm looking for the volume of only one. So you see that the volume of only one is 42 centimeters what? Cubed. So I have the volume now also. So volume equals to that much. The base area, I have it as 35 centimeters. So what is the thickness? Or in other words, what's the height? So I will put here my 42 equals to my 35 centimeters. Times the thickness. So in other words, because I'm looking for t and I've multiplied, I need to divide. So my t will equal to divided by that, 42 divided by 35. So my t is t equals to 1,2 centimeters. Okay, here we go. Let's take note of this. This will now to be summarized a little bit. Okay. Yeah, okay, it's fine. It's fine. It's fine. It's fine. They are telling us, calculate the diameter of the tablecloth to be cut from the material, including the additional centimeters for the helm. Okay. So what has to determine the height? Sorry, the diameter of the tablecloth. Here we go. So this will the diameter will be 130 plus the hanging, which is 25 on one side, plus another 25. You will get the answer as 180 centimeters. Okay, here we go. Calculate the area in meters squared of the tablecloth material. Remember in the scenario, they have told us that the tablecloth material is here, measures 23 meters wide and 23 meters in length. In other words, it's a square. So we shall say 2,3, sorry, 2,3 by 2,3. It's not 23, it's 2,3 meters by 2,3. We said it's a square, so it will become 2. And the answer here becomes 5,29 meters squared. So they are saying calculate the area in meters squared of the tablecloth to be cut by Linda. Remember, the tablecloth, the measurements that we have in tablecloth are in centimeters. You need to change them to meters. So we saw that it has a diameter of 180 centimeters. Change this to meters, you divide by 100. So you have 1,8 meters. This is the diameter. So we are not interested in the diameter because the question wants us to have the radius. So we shall divide this by 2. You end up having 0,9 meters. So go on and we get the area, which will be 3,142 times. The 3,142 represents the pi times the radius, which is supposed to be what? Squared, which is 0,92 squared. So the area of the tablecloth will be 2,55 meters squared. So they're asking us calculate the amount of material wasted when cutting the tablecloth. Get the amount of material wasted when cutting the tablecloth. You may use the formula below. So the area of the material minus the area of the tablecloth to be cut, which is true. So remember, we got the area of the material as 5,29 minus 2,55. You understand? That means you remain with 2,754. But you realize that the materials you're left with, it can make another tablecloth. So subtract the tablecloth again. So area that is wasted is 0,19 meters squared. 19 meters squared. This one is time, and it will be straightforward. Write down the time in which Namibian team finished the race. You come here, look for Namibia. Oh, Namibia is here. Winner. These are the people. How much time did they take? They took. So this is the answer now, because we're looking for the time. So it's 10 hours 54 minutes. That's the time they took. So write down in which year the fastest time to complete the race was recorded. Now we look for the least time here. So we have 11 hours, no. 10 hours, no. 6 hours, 57 minutes, 6 hours, 39 minutes. So we shall take it's this one here. And they asked for the year. So this will be the year, just 2016. All right, there we go. We have a question that talks of this. The Zululand District Municipality supplied 108 households of Zondela community with 6 water tanks. Please turn this into numbers. Turn this into numbers. These are households, 108, not 180. So the Delamutine held a meeting where it was decided that 6 tanks would be shared amongst all the households. The municipality filled tanks with clean water and has undertaken to supply them with continuous drinking water. Should the need rise? Okay. The diameter of each tank is 260 centimeters. The height is 418. Okay, they are looking at this now. How many households share one tank? Remember, households were 108 and the tanks were 6. So we divide the number of households by the number of tanks, and we see that each tank will serve 18 households. One tank costs 4,950, including the delivery. How much did the municipality pay for the tanks? Remember, how many were they? There were 6 tanks. If they were delivered and each cost them how much? So it's supposed to be the answer is 29,700 rands. Okay, we continue and say, what will be the area of the base of the tank in centimeters squared if the diameter is 26? So now, here they're talking of the diameter. In your head, you know very well that the formula requires you to use radius. So the first thing you do, look for the radius, which is diameter divided by 2, which is 260 divided by 2. The answer is 260 divided by 2, you have 130. So you come now, this is your radius. Come and substitute in the formula. Pi, it's 3,142 times. Now you have the radius as 130. But don't forget it has to be squared. So the area is 53,099 centimeters squared. That is the area of the base of the tank. Determine the volume of one tank in meters cubed. In meters cubed. So remember, on top there we had the diameter and the height together. So now I will use the radius here because they need me to have the radius. We already have the radius here. So I need to change this radius to meters. I need to divide by 100. Why am I changing to meters? Because the question wants me to have the answer in meters. So my radius is 1,3 meter. Yes. What about the height? Remember the height, they told us it was 418 centimeters. I need to change that to meters. I divide by 100, whereby I get 4,18 meters. So I'm good to go. First thing you do, they want me to hear the volume of one tank. They want the answer in millimeters. Check your units. If they are not in meters, change them to meters. This is what I was doing here. Centimeters to meters, we divide by 100. So here we are. So volume, I'm going to go pi, which is 3,142 times radius. I have it as 1,3 squared times the height, which is 4,18. So the volume is 22,2 meters cubed. So if 1 meter cubed equals 1,000 liters, how many liters of water tank will this tank hold? So you already have it as 22,2 meters cubed. If you only have 1 meter cubed, you have 1,000 liters. So we have 22. So what do we mean? We need to multiply by 1,000. Multiply by 1,000. The answer will become 2,220. These are liters. Those are liters. Those are liters. We look at question number 3.2. All right, take note. The diameter of the bottle, the diameter of the base of the bottle is 58 millimeters, and the height of the box is 143 millimeters. The diameter of the, now these don't work hand in hand. However, this diameter is for the bottle. Then the height is for the box. So when you just hear that, because now if you have the height of the box, so you have the diameter, you have the diameter of the bottle, but the height is missing. They've not talked about it here. And you have the height of the box. You have the height of the box. But what about its what? With a breadth is missing, or length is also missing. Yes, sir. I'm here reading that. Anyway, and they go ahead and they say the length of the side of the box must be approximately 105% of the diameter. Now you see how we're going to. So okay, you say okay, the length of the, and what you take note of is that each bottle is packed in a cardboard box with a square base. So a square base simply meaning this base here of the box, it's a square. If this is A, also this other side is A. Okay, we continue. That's what you have to know. The height of the box is approximately 102% of the height of the bottle. So now this one here, it gives the height of the box. Anyway, let's continue and we say, calculate the height of the bottle to the nearest millimeters. Height of the bottle. I told you it was missing. Indeed, they are telling you to calculate for it. But we shall use this statement here, the last statement. The height of the box is approximately 10, 10, it's 102%. So what we're going to say, we shall ask ourselves, 102% gives the height of millimeters. What about 100%? What does it give you? Because this increased because this is at 100%. The percentage of the photo just increases by 2% to get the height of the box. What about if it's at 100%? What is it? We don't. What do you do? Cross multiply, which becomes 1/4 times 100 gives me 102 times the b. I divide through by 0.2, divide through by 0.2. So my height of the box equals to Matu. These are millimeters, but they said to the nearest millimeter. So in other words, it's nearest millimeter. The other way around, would say, because they're telling us the height of the box is approximately 10% of the height of the bottle. So for them to get the height of the box, looking at the height of the box and the bottle. To get the height of the box, they took 102% times the height of the bottle, and they got the answer as, you understand? So because you're looking for this, and this is a percentage, divide this by 100, which gives you 1,02 times b equals to 143. Divide through by 10 by 1,02 by 1,02. Still get the same answer. You have the same answer as, which is approximately 140. In order to minimize the cost of cardboard required for the box, the following guideline is used. The difference between the areas of the base of the cardboard box and the base of the bottle should not be more than 11 centimeters squared. Determine whether the dimensions of the card box satisfy the above guideline. Remember, we're going to look for the difference. Difference simply meaning you need to subtract. But what are you going to subtract? The area of the base of the cardboard box and the base of the bottle. They have to be in centimeters what? Squared. Are they? So we need to take note of that. All right, I'll start with, because now we're going to look for the areas. We're going to look for the areas. No, area of the base of the cardboard. Remember, the base of the cardboard is square. Together? A cardboard box with a square base. But this square base, we don't know how much or what is the length of each side. But they have told us the side or the length of the side of the cut must be approximately 10% of the diameter. So you already have the diameter. You have the diameter of the bottle. So let's look at that. Length of the box, length of the base. Length of the base is got by getting 105% times the diameter of the bottle. 105%. 105% times the diameter of the bottle. So here we say 0.05 over 100. Why am I putting it over 100? Because of this sign, times the diameter, which was what? 58. Do that for me. So we get the answer here as 60, 60,9. These are millimeters. We want them to become centimeters. Why do I need centimeters? Because what I'm going to use here is centimeters square. So I need to divide this by 10. I end up having 6,09 centimeters. Well and good. So this will be the length of the base of the box, but it's not the end. So I now look for the area of the base of the cardboard, which will become side times what? Side. Why am I using side times side? Because it's a square. So I'll take the 6,09 times the 6,09, and I'll get the answer as 37,09. These are centimeters what? Square. So I've got the area of the base of the cardboard. So this is done. So I need to look for the base area of the bottle. Remember, the square, the area of the bottle has a diameter of, the diameter is 58 millimeters. Change it to centimeters, you get 5,8 centimeters. I'm not interested in the diameter, I need the radius, so I divide by 2. I get the answer as 2,9. So the radius is 2,9 centimeters. So the area will become pi r squared, which is 3,142 times 2,9 squared. So here I end up having approximately 26,42. They told us to look for the difference because they said the difference must be 11 centimeters. Sorry, it should not be more than 11. So let's look at the difference. So it will be 37,09 minus 26,42. Indeed, it's not more than 11. So they are saying determine whether the dimensions of the box satisfy the above. So you conclude and you say, yes, yes, they do. They do satisfy condition. Yes, they do satisfy the condition. Yes, they do satisfy the condition. That's done. Let's look at question number 4. Question number 4. Question number 4. Question number 4, we look at candles. Candles are being made and they take different shapes. All right, here we have, this one's a cylindrical candle. And on my right, we have the rectangular candle. Together. So they have different measurements indeed. And we shall use different formulas to calculate. Anyway, 4.1, it wants us to calculate the volume in centimeters cubed. Take note, guys. Take note of this. The moment you look at your measurement straight and see, here we have centimeters. These are meters. The calculation has to be in centimeters. But of which candle are we looking at? Calculate the volume in centimeters cubed of wax needed to make a cylindrical candle. Ignore the hole meant for the wing. You understand? So we are looking at it as a whole, and they've given you the formula down here. But take note, what I want you to understand is this: the units. So the meters have to become centimeters. So meters to centimeters, we multiply by 100. Big to small, multiply. So 0,025 times 100, you end up having 2,5. These are centimeters now. This is already the radius. We don't need to look for it. It's already the radius. So all we had to do was to change to centimeters. The height it's in centimeters, so we don't need to change it. So just come, substitute in the formula, which is 3,142 times 2,5 squared times 12,5. So the volume that we have here, it's 245,47 centimeters cubed. Okay. Namasha melts 5 liters of wax a day and pours into the candle molds. Calculate the number of cylindrical candles she makes from 5 liters of wax. Now, we've just seen that only one candle needs you to have, it takes 245, 47 centimeters cubed. These are not liters, but she uses liters to make candles, simply meaning we are going to get the amount of wax divided by the wax for only one candle. So the wax, now these 5 liters have to become centimeters cubed. So we shall use this factor here. So if there are 5 liters, we shall need to multiply them by 1,000 and becomes 5,000 centimeters cubed. So the volume is the wax that's brought is 5,000 divided by, so 5,000 divided by 245, 47. So we have 20, but remember candles can't be half. So here she will only get 20 candles. She will only get 20 candles. Calculate the weight of wax to make a cylindrical candle in grams. Give your answer to the nearest gram. You may use the following formula. All right. Candle weight equals to paraffin wax density times the volume of one candle. So Guys, learn how to substitute it in the formula. They've given you where the paraffin wax density 0.9 grams per centimeter. So paraffin density is 0.93 grams, 0.93 grams times the volume of the one candle. Remember, we got it as 245.47. So 245.47 times 0.93 is supposed to be to 8, these are grams. Take note, they said give your answer to the nearest gram. So to the nearest gram, here we don't need these commas. They have to go off. So it becomes 228 grams. That's how we do this. And let's call it a day. Thank you very much.